Presently, with the amount of money President Obama is giving to the electrical smart grid, this is the hottest area as of now. Companies like Northeast Utilities and United Illuminating are hiring on the spot people with a background in power engineering. Recently, we were awarded the $265,000 grant for 20 seats of the Electrical Transient Analysis Program by Operations Technologies in California. The commercial value of this software is about $1.5 million. Our students use this in most of the graduate level courses, especially to emphasize the concept of power systems analysis.
All kinds of places are employing our graduates, and that's really as a result of the technical training. So we put people through a lot of paces in terms of having to learn electronics, having to learn software. They have to take some math classes, there's no way around that. A good example would be my audio systems integration class. The majority of handouts and study material in that class come directly from the manufacturers themselves. So I'm handing out schematics from Fender, from Peavey, and we're looking at technical literature from these companies.
I'm primarily responsible for the computer-related courses, both in the engineering technology and engineering program. What we cover in the course is mainly the how you can design, you learn how to design the programmable logic devices using the basic logic circuits. And we use the Chorus 2 software for that, we use Altera trainers for it, and we test it using the National Instruments test equipments for arbitrary waveform generators, and we use logic analyzers to measure our outputs. So it's A to Z design and testing performance.
Well, one of the things I think that's good here is that our ratio of faculty to students is low compared to a lot of schools. It's easy to get lost when you're in a large program in a large university. We have quite a few labs, we have quite a bit of electronics equipment. Most of it's the same kind of test and measurement equipment you would see in the industry. So we have oscilloscopes and function generators and voltmeters, and it's kind of fun to go build breadboards and test circuits. We also have a lot of software packages that are used now to simulate circuits.
People ask about computer engineering because we have very strong major in computer engineering. Computer engineering is all about interfacing. When you go to the grocery store and you see the self-checkout, that's computer engineering. You have the software, you have the hardware, you have the sensor, you have the barcoding, you have the weight scale where you scan a gallon of milk, you put it in. If it's not gallon of milk, it'll say something else. If you put a bottle of wine, they will know it's not gallon of milk. That's computer engineering. So those are the things I do and I teach. I teach also a junior level course called Engineering by Design, where students learn about entrepreneurship, how to work together, how to choose a product, how to start a company, how to finance a company, all the patents and the copyright, all those details.
So I taught both the senior level digital signal processing and the graduate student level digital signal processing. And for that class, it's really sort of one of the class they can use to find a job with. You know, it's very, and that major is very career oriented. It's actually one of the most popular class.
The electronics industry continues to grow dramatically in the United States and around the world. It's an area that needs many, many new, young, technically trained people to enter these fields, to continue to fuel the worldwide need for computing systems, telecommunication systems, and advanced electronic controls.